Welcome to the group exhibit Hydrogen and Fuel Cells here at Hannover Fair 2013. My name is Alexa von Busse, I'm your moderator for the session, and I invite you to take a seat, as long as you don't have one right now, and have a drink and listen to our next conversation. I'd like to introduce my guest. He's a member of the managing board of FuelCon, a company specialized in testing, assembling and diagnostic systems for fuel cells and batteries. Please welcome Mr. Mathias Bode. Hello, Mr. Bode. Have a seat. So, as this is a public forum, I'd like to remind the audience first that you're really welcome to ask questions. Just raise your hand and I come around with a microphone whenever there are questions coming up. Okay, so Mr. Bode, please give us an image of your company first. Where are you located? What are you doing?
Yeah. Thank you for the introduction and good afternoon to everybody. FuelCon is a German company headquartered not so far away from here in Magdeburg. It's about 1 hour car drive. And we provide test and diagnostic equipment for several types of electrochemical energy converters. That includes fuel cells, this includes batteries, but all other of these exotic types of converters like redox flow batteries, like we see an electrolyzer as an electrochemical converter. And we are in this business since nearly 20 years. And we try to cover everything what is necessary about testing of these converters. This begins with the real electrochemistry. That means we provide equipment where you can qualify single cells, materials, catalysts. And then in the next step, we provide equipment where you can qualify and test short stacks, smaller systems, smaller stacks, smaller batteries. And finally, we supply to several customers equipment for complete systems. For example, fuel cell systems, solid oxide fuel cell systems, PEM fuel cell systems, or complete battery propulsions. That is nearly what we produce.
So you test the whole range from small to big,
yeah.
From applications to systems.
Yeah.
Okay, what kinds of tests are frequently asked?
That differs from the test item or from the test duty. If we speak about cells or single elements, we mostly speak about durability and long-time test. That people see on the cell level degradation, for instance. Then a second main task is to really collect data from cells as well as from short stacks, to have a large database in the laboratory that you can identify typical operation windows for your final systems. That is the real value of our test equipment, because if people buy test stands, they don't have a payback or a return on investment. What the test stand creates is data, a lot of data, and this kind of data can be found later on in fuel cell management systems or battery management systems to have a real good operation condition of the final system as well as diagnostic functionality. And this is, let me say, the two main topics. A third topic that is, let me say that our test equipment is mostly in the R&D field, research and development. That means at the end we provide a little bit or a kind of test equipment for validation. That includes not only the electrochemical testing, but further on climate and temperature testing, vibration testing, which is more related to the final systems, to the final product. But this is nearly the end of our product range.
Okay. As we are talking about fuel cells and batteries, do you see batteries stepping forward again?
This is a good question. I like this question. Yeah.
That's good.
There's no general answer on this. We are involved in battery test equipment as well as fuel cell test equipment. That's why I think if we speak about batteries, we can focus on the automotive field. And then there's no general answer what is better or what is the better solution. If we understand that about 70% of the daily driving of one person is below 30 kilometers. That means if you understand this, you see, okay, battery is maybe the better solution because a battery car has a range and mileage of close to 100 kilometers. But if you want to drive in your vacation
Yeah.
down to the south by Bavaria or Italy, then you need another kind of car.
So from your point of view, the general range is about 100 kilometers, because I read numbers like 400, 500.
Yeah.
Companies are coming up with these numbers.
I don't see any technology in the battery field which brings you more than 150 kilometers.
Okay.
I don't see this technology in the laboratory, I don't see it in the field. That is one challenge. The second challenge is the charging. If you fuel a hydrogen car, it's a question of 5 minutes, something like this. That is what the driver expects. Yeah? If we speak about charging of a battery car, it is a question. It's a still unsolved question. The quick charging capability, reduce lifetime, and so on. But again, if you drive each day from your home to work with less than 50 kilometers, you have enough time to charge your car.
Yeah.
You can use this. For the car industry, it's a good possibility because they can sell a daily car and they can buy or can sell a vacation car. Yes, that is.
So let's summarize. There's a big field there, and there are improvements to make.
Yeah, I by myself, yes, a strong belief in the fuel cell car, because only the fuel cell car or the hydrogen car will give the answer to all of the challenges, carbon footprint, and all of the other issues, and will solve the mileage problem.
Okay, yeah. So what I wanted to point out is that there's a big improvement to make concerning batteries, and that's why I'd like to take the chance to announce that from the beginning, from 2014 on, our name would be Group Exhibit Hydrogen Fuel Cells and Batteries. Just to let you know.
Yeah,
So
but if you look to our wonderful booth straight over here, you see that
right
we
there.
cover both battery testing as well as fuel cell testing. Yeah.
Yeah. Okay. Yeah. Let's get back to the pictures there, or to the testing stations you have there. How does the testings themselves work? How do you do it?
Yeah. Generally, we bring the fuel cell in all of the possible conditions during their operation. That means we simulate the different fuels, not only hydrogen, but if you want to see influence of different hydrogen sources, you can simulate reforming conditions, you can simulate other contaminations in the fuel gas supply. And then we simulate the cathode air supply in terms of gas composition. You can work with oxygen only, you can work with air. You can see which kind of pressure and humidity conditions I supply my fuel cell. And on the other hand, we can simulate the different kind of system pressures. And finally, what is interesting for the customer, we simulate the thermal load as well as the electric load to see how is the efficiency, how is the dynamic of the system of the fuel cell, and give the customer this kind of values that he can take his expectations or can see if his goals will be achieved.
This sounds pretty complex. How many employers do you have for that?
Okay.
Just to give us a number.
It is, let me say, 50% of the companies are engineers. Completely, we have 50 staff members. 50 of them are engineers working in electrical, mechanical, and software engineering. And a separate group of engineers is completely involved in working with customer to support customers in defining test runs, defining test programs and test campaigns, because we have collected over the years engagement in this field, a lot of understanding about durability testing, about different kinds of accelerated testing, as well as qualification and organization of test fields and test data.
So yeah, I think this is the big difficulty, to define the testings, right? To find out with the customer what they need and what you have to program. So yeah, let's get to the stations you have. You come to the customer with the stations, and then you begin. Can you draw the whole process of a project for us?
Yeah, there are different approaches possible. One approach could be that we start with a proven application from our side. These are typical customers, are system integrators, that they say, okay, my plan is to create such a system, maybe an CHP system, combined heat and power system, with an 1 to 2 kilowatt SOFC stack. And then we can give him recommendations, what is necessary to have around this. Typically a test station to qualify stacks with a furnace capability, but I would recommend him to invest more in equipment for hot boxes, that he can test SOFC stacks in an isolated box, that he can more integrate his own equipment, reformers, afterburners, heat exchangers, blowers, and so on, into his test plans. But let me, in this, especially for SOFC, it's interesting to come back to this test program definition, because I mentioned this accelerated testing. If you understand that an CHP system must be qualified for a lifetime of 40,000 operation hours, yes, these are some years. You cannot start testing for 40,000 hours, see what's happened, make an iteration in your R&D process and start again 40,000.
That would be kind of time wasting.
Yeah, absolutely, absolutely.
So what do you do?
Yeah. Now the real value, what we can give to the customers, that we can give him recommendations to project a lifetime of 40,000 operation hours into a test time of maybe only 1,000 hours. It has to do with the various with the simulation of various loads, that the electrical and thermal cycling is much more dynamic. For instance, this is one approach coming more from the test equipment. The other approach is that you can define smart methods to see more earlier what's happened within the fuel cell. For this, we have in our product range some kind of analytical equipment. One of these tools is impedance analysis, for instance, and we provide in the test station integrated impedance analyzers, that they see very early in which parts of my system, of my MEA or of my stack, I see very early some effects of maybe thermal cycling, of material contamination, or of my operating procedure.
Do you see both? Do you see positive and negative aspects or affections?
The positive is that you see nothing. That you see, okay.
So that would be positive.
But this is not really appreciated, because typically if you want to have a response, you must see some deviations. That's for sure. That's why if you have a final solution, or if you think, okay, this works well, the specification is fulfilled, then you must, or you have to provide this 40,000 hour operation test, that's for sure. Yes, but this is then for the final qualification of the product, not for the research and development needs.
Okay, we talked a lot already. I want to remind the public that you feel free to ask questions whenever they come up to your mind. Just raise your hand and I come around with the microphone. Okay, so you provide your customers with everything, with the questions, with the definitions, with the testing stations. How do they know how to handle these testing stations then? Because you leave after you install them, right?
Yeah. There are typical procedures within our customers. When they say, okay, I plan to establish a test field, the customer by themselves think about training and support activities. At this time, but some other customers don't do it. But for this we provide, let me say, a complete range, starting from standard service duties. This includes typical calibration of the equipment, because you have to prove, you have to check constantly if your sensors will give you the right values. If the temperatures, gas flows, compositions are within specification and accuracies. And then a test equipment is let me say, a living system. And you have issues over the lifetime, you have the need for maintenance, and for this we provide different versions of maintenance contracts. Typically we have a preventive maintenance that we come in a defined period to check the equipment to see if safety chains are working well, if electrical connections are working proper and so on. And depending on the results of the corrective maintenance procedure, we propose the customer some kind of corrective maintenance. That you see, okay, this sensor is outside the specification, we can make an adjustment, we can make a replacement, something like this. That is one side. Second side is that we provide more engineering services. That we, as already mentioned, we provide the services to define, to help the customer to organize test field and test runs. And we create for the customer the test programs, so-called test scripts. These are programs for the automatic unintended operation of our test equipment. And in a third step, we provide several stages. If customer has new requirements, then we speak about replacements, debottlenecking, revamping, and so on.
Referring to the periods you just mentioned, how long does a project run from beginning to end, normally, or an average?
Yeah, some project never ends. Yeah. We work in an innovative field. That means sometimes if customer releases specification, then in the next step of negotiation, let me say, the agenda has changed and the specification needs to be revised. I remember it was at the end of the 90s when the car industry decided to proceed with fuel cells. It was still unclear whether methanol or hydrogen will be the fuel. And I remember a project when the customer ordered 3 methanol test stations. And 1 week later he said, oh, all car makers take the decision, we will run with hydrogen. Can we change from methanol into hydrogen? That is, let me say, we are prepared to handle this, because if we work in a field where the product doesn't exist actually, we have to find the proper way to help the customer when specifications are changed.
Okay.
But the question was how long the project.
But yeah, it depends.
Yeah, It's actually the production pipeline is really full. That means actually we speak about 6 to 8 months.
Okay.
We try to reduce this, but there's typically no project faster than 6 months.
Okay. Okay. All right. I'm sorry. I think we ran out of time. Yeah. I already noticed. I'm sorry. The next moderator is already waiting. So if there are questions coming up to your mind, then follow Mr. Bode to booth number C64.
The booth is straight over there.
Straight over there. Right. And help me to thank Mr. Bode with a warm applause. Thank you.